Okay, so hello, this is section 3.5 with video 1, transformation of graphs. Transformation of graphs. Okay, so first what we're going to talk about, vertical shift up. Vertical shift up. Transformation. Okay, so let's talk about definition. F of x is original function. Okay, so new function, which is f of x plus d plus coefficient, is the vertical shift of original function f of x by d units up. Okay, so technically if we're going to have a transformation, you're going to see the new function which looks like original function just by adding extra coefficient. That means we need to shift entire graph by, let's say, 5 units up. Okay, so let's talk about the example. You have f of x, it's been original function which is equal x. And then you're going to see function g of x, which is equal x plus 5. So like you see, the g of x technically looks like f of x. We're just adding 5 extra coefficient. So what that means, and of course g of x is a new function. So what that means, that original function f of x was shifted by 5 units up. Okay, was shifted by 5 units up. Okay, next what I want to talk about it's going to be vertical transformation down. Vertical translation down d units, and you're going to see that from original function we're going to subtract the integer, usually the coefficient. Example, f of x, it's original function, it's equal x. That's the original function. And what's going to happen? G of x, it's a translation of original function. It's equal x minus 5. So like you see, g of x looks like original function. The only change that we have that minus 5. That negative 5 tells you that the original function was shifted down 5 units. Okay, so we're going to do the example. Let's do the example. Use graph. I'm recording, sweetheart. The lesson. Use graph f of x equal x squared to obtain the graph g of x, which is equal x squared plus 3. So like you see, g of x looks like original function. The only change that we see that plus 3. And what we'll need to do, find the domain and range of g of x. Okay, so let's continue. Let's solve it. Let's put the solution. So g of x is a vertical translation of f of x by 3 units up. So what I recommended to do it, grab function x squared, find couple points, and then use the information that g of x is the same function but just push 3 units up. So to the new x values will stay the same, but the y values will change by adding 3. So let's create the table of values. Table of values. Table of values. So we have function, we're going to graph original f of x, which is equal x squared. So we're going to pick 3 nice points. X, y is just equal x squared, and we need points x comma y. So when x is equal 0, y also will be equal 0, because 0 to a second power is equal 0. So we're having point 0 comma 0. Okay, next let's pick x equal 1, so y is equal 1 square, which is just 1. So we're having point 1 comma 1. And let's make x equal negative 1, so y is equal negative 1 square. Negative 1 square, come on, which is just 1. So we're having point negative 1 comma 1. We're going to graph them in a second. And now let's talk about graphing g of x, which is our translation. So don't forget that g of x has equation x squared plus 3. So what happened here, let's write a note for you. We will use original points, x coordinates are the same, y coordinates will change by adding 3. By adding 3 to the original y coordinates. So again, let's create a table of values so you will see exactly what's going on. So now we have x, g of x, which is equal x squared plus 3. And let's talk about points, x comma y. So I'm using exactly the same x coordinates, 0, 1, and -1. 0, 1, -1. You can always plug it into the equation, however I'm not going to do it because we already know that we have that vertical translation 3 units up. So what I'm going to do, I'm going to use the original y coordinates. So when x is equal 0, originally we got 0, however now we're not going to have 0, we're going to add 3. So the g of x will have 0.0 comma 3. Because we have that vertical shift 3 units up. So again, to original y coordinates, I just add 3. Okay, now when x was equal 1, originally from function f you had y equal 1. Now we have that vertical shift 3 units up, so we're having 0.1 comma 4. And then when x was equal -1, from function f, original function, which was only x squared, we had y equal 1. Now we're not going to have a 1. Again, don't forget that we have that vertical shift 3 units up. So we're adding 3, so we have a point -1 comma 4. What we're going to do next, we're going to graph both. So graph f of x and g of x together. So we can see that vertical transformation. We have points for each function, so let's just plug it in. Y, this is x. F of x will be in black, which is x squared. That's the parent function, original function. You have 0.0 comma 0, 1 comma 1, and then it was -1 comma 1. So this is the graph of f of x. And in blue, I will graph g of x, which was x squared plus 3. So we had 0, comma 3, 1, 2, 3. When x is equal 1, we got 1, comma 4, right here. And when x was equal -1, we also got 4. So we have nice points, and that's how g of x looks like. Oops. So this is g of x. Okay, so like you see, the same shape, we just move entire graph 3 units up. Okay. Now, next what we need to do with this problem, we need to find the domain. So let's continue. Find domain of g of x. Okay, let me put that g of x in blue, because g of x we graph in blue. So let's find domain of g of x. So like you see on the graph, domain of g of x, this is your function g of x. You can pick any x you wanted, which means domain will be all real numbers. The x is from negative infinity to positive infinity. Domain represents x values, of course. So domain of g of x is the same as the domain of original function. F of x, original function, before transformation. No changes. Now we need to find the range. Range of g of x. Again, g of x is the function x squared plus 3. Let me first write down that is not the same as range of f of x. So let's go back to the graph. Range, that's the y values. Like you see, the g of x starts from 0, 3, which is the origin, so the range will be 3 to positive infinity. The range of original function was from 0 to positive infinity. So since we have that vertical shift, the range will be different, always. Unless the range is all real numbers, so then there's no change. But here the range of f of x, in parentheses, I will put that the range of f of x was was 0 to positive infinity. Now range of g of x is 3 to positive infinity, so that function exists only for y values from 3 to positive infinity. Okay, I'm going to stop here and then I will continue with the next video soon.